This writhing mass of epileptic squares is the result of a system called Conway's Game of Life, and if you clicked on this video, I can assume that you've probably heard of it before. If not, that's fine, but I highly recommend you check one of the links in the description for a more thorough explanation. Now before we get started, I am sure there are loads of dependencies you can use to make this better or faster than what you see here, and I am sure there are countless ways to use the standard library better or faster than I have. Oh well, the goal here is to make a program that someone straight from Codecademy can open, understand, and edit without having to spend 20 minutes figuring out why pip install won't work. Here's how this is gonna happen. We're beginning at line 1 and working down. I don't like long tutorial videos, so this will be quick, very quick, but I will explain everything, and if you need to go back to a particular function, there will be a timestamp in the description. First, create a file called life.py or some such, and in the first 2 lines you're going to import tkinter and random. Because we're using tkinter, go ahead and define the window you want to visualize the program, in this case a 600 by 600 white canvas. Now make a dictionary called grid, and within it we'll key a value called xy and a list called nodes. Later, this will become the basis of a grid structure that is xy nodes to a side. Now we'll define a class, node, and give it the following init values. Node.xy is a list containing the object's position on our grid. Node.on and node.next are Boolean values, which equate to whether the node is alive in the current cycle and if it will be in the next one. We'll also give it a rendering function so that when the node is in its on state, the program will draw a black rectangle at its position in the canvas. Now it's time to actually construct the grid, and to do that we'll define a function called genNodes. All this does is iterate an ij loop over our maximum xy values defined here, and then append a node to our grid list with coordinates ij. Now give that a run, and make note of the fact that we have a list with 40,000 objects in it. But we have one more thing to do before we move on, and that is to define each node's neighbors. You see, we can determine adjacency just by checking every node's xy position, but doing this every time for every node in every cycle gets expensive. Instead, we'll be giving each node its own adjacency list called node.neighbors, and it's this that allows our program to remain efficient despite having such a large amount of nodes. Now we'll define a function called getNeighbors, and within it declare a temporary list and a counter variable I. We iterate through our node list and append each node to our temp list. This will make our temp list an exact copy of the original node list. Now we loop through our node list again, designating each node as N1, and we will also pop the first index of our temp list. This keeps us from checking the same node twice, and it will make this whole process a little bit faster. Now we loop through our temp list again, declaring each variable as N2 and passing an if statement to make double extra sure that nodes never place themselves in their own adjacency lists. The following 2 if statements compare the xy coordinates of both nodes, and if they are directly adjacent, they are appended to each other's neighbor list. We'll also increase our counter by 2, and this will keep track of the total number of connections in our grid. After this, we'll see if N1 has 8 or more nodes, since the maximum number of connections any node should have is 8. When a node has this number of neighbors, or when we've looped all the way through the temp list, we start again from the next N1. Finally, we'll print a statement so we know exactly how many different connections are in our grid. For a 200 by 200 grid, we have 317,604 neighbor associations. Abstract relationships like this are the subject of graph theory, and we really don't need to get into it. Now our grid is constructed and connected, we can actually get to the rules of Conway's Game of Life, which state that any node or cell in the grid can be either on or off. Nodes that are on remain on if exactly 2 or 3 of their neighbors are on. Nodes that are off turn on if exactly 3 of their neighbors are on. We can implement this in a pretty simple fashion. Define a function called ruleCheck and iterate through the grid list. For each n, we'll set a counter I starting at 0. We then iterate through each of that node's neighbors, and for every on state, we increase our counter by 1. Once we're done counting the neighbors, we'll have 2 nested if statements. First, if our node is on, and if our counter equals 2 or 3, our node.next will equal true, and if not, it will be false. If instead our node is false, and if our counter is equal to 3, it will turn on. This will become the core of our program cycle. We'll also want a function that can randomize our initial state. Define a function called scatter and create another counter variable I. We'll iterate through our grid list again, and we'll also limit ourselves only to the central 40 by 40 square at the center of the grid. We'll pass a random number from 0 to 100, and if it's less than 50, we'll turn that node on and increase our counter by 1. Lastly, we'll print a statement letting us know how many nodes are on at the start. To tie it all together, we'll define a function called live in all caps and give it a parameter which I have defined as lim, which stands for limit. Also set another counter, but since this function uses other functions inside of it, make your counter f for frames, and again set it at 0. Initiate a while loop with the condition that the frame number is less than the loop limit, and for each iteration we'll increase our counter by 1. Run our rule check function, update our nodes, and then render the output. This uses that canvas widget from the beginning of the video. Now we're done and we can run our program. Set another for loop with a range of however many times you want the grid to reset. Start your loop with the scatter function, and then the live function set for how many frames you want each iteration to cycle. Don't forget to declare your main loop at the end. Run your program and you should see something like this. If you don't, there's something wrong. Thank you for watching. Please like and subscribe, and if you have any questions, comments, or suggestions for future videos, please leave them below.